third day of PyWorld. How's everyone doing? Good? Ready to talk about writing high-performance applications with the AF SDK? I like the excitement in this room. I mean, already, let's go. The room is kept at a nice cold temperature because, you know, best high-performance code runs on cold computers. So, I mean, everyone knows that. This was by design, so. Anyway, let's get started. I am Shrey Satpathy. I am a product support engineer specializing in developer technologies here at OSIsoft. So when someone has a problem about slow-running AF SDK code that they've written, they call us and they probably get me, or someone like me. With me, I have my co-presenter, Jason King, who is a senior software developer for the AF SDK team. And together, we'll be talking about the vast subject of writing high-performance code with AF SDK. Now, before we get too deep into the weeds, I just want to gauge the room. How many people, show of hands, have written code before? All right, everyone, nice. How many people have written .NET code before? All right, still a significant amount, good. Let's keep going. How many people have written AF SDK code before? All right, nice, we have a good crowd here. How many of you have ever faced issues with the performance of your AF SDK code? Few hands going up, I see you. All right. So this talk is aimed at folks who have a desire to build scalable applications against our infrastructure. And in the next hour and a half, we're going to have some fun with it. I promised Rick that we will, since this is such a vast subject, we can't talk about everything in 90 minutes. We're going to focus on these 5 main topics. Data retrieval from the data archive, different methods to do that. Then search, AF element search, find elements. The whole topic of event frames and how to get the most value out of that. AF and Py data pipes, and also the AF data cache. Now, I just want to talk about the basics when it comes to designing a performant application. This illustration over here kind of drives the point home. The most popular RPC used on the data archive is get snapshot value. The client requests, hey, give me the snapshot value for this particular tag. Server looks up in its snapshot table, returns that one value to the client. Now we make 2 calls, and you see both times gets that latency hit because the client has to go to the server and come back. You bundle those calls together, you barely see a difference when you make 2 calls for 2 snapshot values. When you do 100 calls, but you send that request in bulk, you see a little bit of a difference, but still, if latency is the thing you're trying to write performance applications for, what should you do? Make less calls to the server. That kind of, it's really easy to think about, but I see a lot of AF SDK code where they're thrashing the server with hundreds and thousands of calls, and then it's not scaling well. Other things you can do, make calls in parallel to utilize your idle client cores. Yesterday there was a talk on concurrent programming where they showed a really nice graph. In the last 5 to 8 years, our client machines have gotten really strong, really beefy. You would have servers 10 years ago that are as strong as my client machine. The other thing we have to do is, let's say I make a big request, give me a year's data for 100 tags. If the server gives me all that data, how am I going to process it? So that's where it comes to utilizing paging the results. Page those results as they come back, and then do something with it as you keep going along. This also helps you minimize the memory footprint, so you're not keeping all those objects in memory, and you can start processing them as they come to you. I actually overheard before the talk that the AF SDK cannot be used to go to the data archive. It's not true. You can get PyPoint data from the data archive using the AF SDK. It directly goes and gets all that data. So this slide here, data retrieval basics, is only to drive that point home. You can write applications for tag-based data using the AF SDK. very important point before we dive too much deeper into this. So for the next little bit, for my live coding session, I'm going to focus on reading data from the data archive. And looking at the room, but when I gauged it, I'm sure you all have done this at some point in some way or fashion. Now we are going to dive into some metrics. What is performance without metrics? If you're saying, my application is running slow, I don't know. What is slow? Therefore, we have the OSIsoft.af diagnostic namespace, where you can actually time how long your RPC calls are being made and get that rendered to the client. We're going to use that a lot in this talk, so I just wanted to make sure you're aware of that. It's fairly easy to implement in your code. You maybe don't want this piece of code in your production application, but when you're designing and developing stuff, you definitely need to keep track of the metrics that you're getting from the server. All right, now let's dive into some code. We are going to focus on just a simple serial query. I want some data from the data archive. All right. So here, before I do anything else, I want to put our tenets down. Performance 101. This is what we're trying to optimize for. Minimize calls to the server, make calls in parallel, utilize paging, and minimize your memory footprint. All right. So I'm going to go ahead and initialize some properties here. All I'm doing is getting some predefined values. So I'm setting the number of pipelines I want to get from data archive server. I'm giving it a start time, giving it an end time. The connection to data archive method, fairly straightforward, and it's just giving me a PyServer object. Now, I want to generate my PyPoint list. What I'm doing here is randomly generating a PyPoint list based on how many PyPoints I want from the server. And all boilerplate code, but essentially, at the end of it, I get this random PyPoint list, which contains 100 PyPoints. And before I move on, can everyone see in the back? Everything's good? Font size is OK? All right. Awesome. OK. So now we are going to write the driver code for the serial query. And here, you notice what I'm doing is instantiating this metrics class. This class right here was written by one of our technology enablement engineers. And you can find it on PySquare. It's posted. You can download it, use it in your code. And all it does is defines an easy interface to get those RPC metrics that I was talking about. All right. Now, let us go back to all right, so I have to implement this runSerial method, which is going to pass in a random PyPoint list and a start time, end time. Fairly simple, right? And what I'm doing here is that's my data archive name. I'm getting 100 points. Go back 3 days. Anakin Skywalker, anyone? Yeah. There we go. Awesome. All right, so let's go implement this serial query. All right. So this runSerial method, again, takes in that PyPoint list, start time, end time, construct an AF time range. This dictionary I'm defining is where I'm going to store the results that come from that. It's a dictionary of PyPoint and AF values. All right. Now, I also instantiate a stopwatch object so I can time exactly what's going on in there. And then I've used this for each loop to go over every PyPoint and make a recorded values call right here, which covers that time range. I'm choosing the AF boundary type to be inside, and then not passing any filter expressions. So if you just hover over it, you can see what that method accepts and look at the overloads. Anyway, fairly straightforward stuff, right? Now I'm going to ask a really important question, which, how long do you think? So I'll give you a hint. There's 500,000 events, give or take, in that time range for this data archive and for these points that I'm going to be using. How long do you expect this to take? A few seconds? 100 points. for 500,000 events.
Each or total?
Total.
Okay. Yeah.
So again, these numbers, this is completely guessing. This will change in system to system, but for this system, I'm going to run that, and we'll see how long it takes. So I heard a few seconds, 2 seconds, 3 seconds. Remember, this is a serial query. The serial query, we're making 100 calls to the server back and forth for that time range, right?
Yeah.
We're going to be here all day. I'm kidding. We're not. But let's see. Did I hear 10 seconds? Oh, there we go. 9 seconds. So there were 492,000 events in that duration. And, so here is the output for the RPC metrics that we get. So there's this get arc events call. That is the RPC that's triggered on the data archive when you are making a recorded values call. All right? So you can see if these are so the get states is for digital state sets. That's another RPC that gets triggered. But the one I want you to focus on is the get arc events. So there's 100 of those being made serially. Each call takes 56 milliseconds, adds up to that, and then processing all of that data, that's what you get. So it took about 9 seconds to get all of this data. And now remember, these machines are virtual machines. We're not performance testing here. We're just showing ways we can get data and how can we get data more efficiently. All right, so any questions about serial query? Everyone's probably done this. Simple, we just make a lot of queries, right? All right, now let's get into some fun stuff. I'm going to comment this block of code out so we don't run that again. And now I'm going to, before we do that, I'm going to put my quick thoughts out. I forgot I had put this in the comments. So quick thoughts, super easy to write. You saw how simple it is and how easy it is to understand. But remember, you're making several calls to the server. You're getting that latency hit with every call. So you have to wait for each call to complete. Never going to be the most efficient way to do things. All right, now let's set stuff up for our parallel query. Exact same setup. I'm using the same metrics class library, and I have to implement this run parallel method, which accepts the same arguments. Let's go ahead and do that. All right. So in the parallel query, I will start by instantiating some basic properties of that method. I take in that time range. I instantiate my dictionary for the results map that's going to store all my data that comes back from the server. And now, what I'm going to do is use the .NET construction of a parallel for each loop to parallelize these calls that I'm making to the server. .NET makes it super easy to implement this. However, remember, with great power comes great responsibility. You do not want to run a parallel for each loop without constraining the degrees of parallelism that you want to let .NET make how many threads for, right? So in my case, my client machine has 4 cores, 8 logical processors. I want them all to be used. I have these processors, they're just sitting. I might as well use them, right? So what I do is I pipe the pipe point into the same recorded values call. And the arguments are exactly the same. However, one important thing is happening here. When I'm incrementing this, I have to lock that events read variable so that all these threads don't write to the same thing, right? Fairly straightforward still. I mean, .NET makes it so easy. I remember back in the days of the message passing interface, I remember Fortran was my first language. And we had to use, this would take 100 lines of code. So now it does not. And now I'm going to write some output just so that we have the same formatting. How long do you guys think this will take compared to the serial? Ooh. I like the ambition in the audience. Let's see. Let's see. I counted 2 already. OK, it took 3 seconds to finish that query, 3.4 to be precise. So now if you see, this was 9 seconds. The whole RPC took 9 seconds, actually, if you just add up those numbers for each individual RPC. But I'm doing this in parallel. So instead of taking 9+ seconds, it took 3 seconds. So things to remember when you're trying to program for scale, use those client cores if you have them, right? And again, this is going to vary from machine to machine. If you have more, if you have less. However, and it does include one interesting thing where you do have to lock your objects. The programming is not as straightforward as just making a serial query. But as you see, it's not that much difficult, right? OK. So in this case, what have we really done when it comes to the 4 performance tenants that we were talking about earlier, right? The system threading namespace makes it super easy to write this. It can be a little harder to debug multi-threaded, like parallel for each loops. Maybe a little harder to understand. But remember one thing, you're still making the same number of RPCs to the server. You're still making those 100 calls. You're doing so in parallel, but still, the server is going to get hit with those 100 RPCs. We did utilize the idle client cores, and I already mentioned about the max degrees of parallelism. So what next? What have we not talked about out of our core tenets that I define up here? We haven't utilized paging yet. Luckily, who here has heard of bulk queries for the AF SDK? All right, we have some people in the audience who've already heard of bulk queries. Bulk queries basically abstract away from the end developer the paging process. So we're going to see how we can do that. All right, so I'm going to set up for my bulk query. I have to implement this run bulk method. It takes in the same arguments as everything else. All right. So let's put in the driver code for that. You notice here, what's different here out of everything else that I've showed you earlier? Yeah, what is this paging configuration object? So as I said, the AF SDK developers did abstract away that paging that you do on the server or on the client side. However, you have some control over how the paging is done. This paging config object is how you specify how you want to page the results that come back to the client. So what I have done here is essentially talked about the parameters that you have within the paging config. Let me scroll. All right. So in this case, if you look at the paging config object, it takes a page type and a page size. That's the minimum number of arguments you need to give to construct a paging config object. The page type specifies how the partial results will be paged back to the client. So you can do this either by tag count or by event count. So in this case, I told you I have 100 tags, and I have a page size of 100 points. How many RPCs will be triggered on the Pi server? Yes, 1. Only 1 RPC. Also, fun fact, the bulk queries run on a separate thread pool on the data archive. So you're not impacting other users when you're making these bulk queries. You have a dedicated thread pool for these queries to run on. There are other overload parameters here that may or may not be useful to you, but these are just knobs you can turn in order to tune further performance. Such as operation timeout override. You can override the timeout, AF SDK timeout setting for this one call. You can have a keep alive timeout for how long, for the maximum amount of time allowed to elapse between the calls to the next. You have a bulk payload % threshold, and you have the maximum number of retries it will do, let's say, if one query fails. All right, I think that's enough about the paging config. Let's see how this actually comes in action. All right. So what we need here is a try block. I'll let you know why the try happens. And then I will have these 2 catch blocks. Now, this is done because the actual error, that if in case an error happens during the query, the reason for that error is actually stored in the config object's error property. So that's something important that you need to catch whenever you're implementing bulk queries. And now, what I'm going to do is copy this try block. And there we go. So what here I'm doing is returning an enumerable of AF values in list results. And look, if you look closely at the call that I'm making, it's still a recorded values call, but I'm passing that config object in here. That will tell the AF SDK how you want to page your results back. So as we mentioned earlier, our page size is 100. We expect to see 1 RPC being triggered on the server. And this is how you would catch the exceptions that you would need. Though I need to instantiate a stopwatch. There we are. Perfect. Looks good to me right now.
Start the stopwatch.
Oh, my bad. Yeah, sw.start. There it is. All right, so how long do we expect this to take? Remember, so bulk queries are great at bundling these pi points together. And the biggest advantage you get out of a bulk query is with the latency here. You're making that 1 RPC call, right? These servers, the client server in this case, are on the same subnet, same domain with less than a millisecond latency. So you actually might not see that much of a performance gain for something like this. So we see 3.5 seconds is what it took. Oh, sorry, never mind. That was the parallel query. I forgot to comment that. But bulk query took 6.8 seconds, actually. And you see there's only 1 RPC being triggered called arc bulk query right here. All right, let's go and comment out that piece of code for the parallel query. There we go. So far, since there is not that much latency on this network, I don't see that much of a benefit with using this bulk query, right? But the prominence of this method will only be in high latency environments. How many of your networks, like what kind of latencies do you experience when you're developing these applications? Is a millisecond pretty normal? Let's say you're getting data from some offshore Pi server somewhere. So again, these are just techniques which you can develop against, and these are knobs you can tune to further improve performance of your applications. All right, so now what I'm going to do is go ahead and change that page and config object a little bit. Let's play with that. So instead of doing that, I am going to do 10 points. So I'm going to page by, I don't want a page to have data for more than 10 points at a time. What are we expecting to see here now? How many RPCs are we seeing? Well, let's see. I don't know. All right. There we go. Oh, I accidentally exited out of that. My bad. Yeah, don't press enter when console applications are running. So in that time range, you would expect to see about 500K. Yeah. So this is fairly dense, but again, I want to do this in a short enough format, so we're not going to wait here for 10 minutes for every query to run. Let's see. This time, we see something different, right? We see, you were right, we do see 10 RPCs. But what kind of RPCs? There's the arc bulk query, it's 1. And then it makes these arc bulk query chunk fetch 9 times. That's the paging going in and getting more data for each of those bulk queries. So you split it up, and then the object is instantiated in the background, and then keeps fetching those tasks. So this is all abstracted away from the developer. Biggest place where you would see an impact for this is high latency environments, which a lot of our customers operate in. It also gives you the feature of bundling your whole query into one. So that, I think, is good about bulk queries. So we talked about serial, we talked about parallel, we talked about bulk. Why not do them together? So next we're going to talk about setting it up for bulk and parallel together. Let's do that. I mean, I have the idle cores on my machine. Might as well use them, right? And use them for the bulk queries. Oh, not that one. Oh yeah, there we go. First, I want to talk a little bit more about the bulk query. First thing is there are fewer RPCs to the server. Shines when latency is a problem. Data is fetched in pages, and the partial result handling is abstracted from the user. There is a dedicated thread pool on the server, which I did mention, to execute these requests, so you're not impacting other users of your data archive. How many of you have a data archive dedicated for you? Data archive is supposed to serve all your users, right? So this really helps. Then the paging config object gives you those knobs, which you can tune your performance on. All right, so now I'm talking about the bulk and parallel together. Let's comment this guy out. So here I'm going to do the exact same thing I've been doing in the past. Instantiate that metrics library, and then go and implement the run bulk parallel method. All right. So you see this method I have pre-written here? It's a boilerplate method. All it's doing is splitting up a list into other lists. And you'll see why I want to do that. The bulk queries usually take in a PyPoint list object. So what I'm going to do is split my 100 PyPoints into lists of PyPoints, and then run them in parallel. There we go. So run bulk parallel. Here, as you can see, I've also instantiated a concurrent dictionary here instead of a regular dictionary for thread-safe operations to additions to the dictionary. I still have the page and config object, and I have this set to 10. Let's go here. So this piece of code, all it's doing is telling it how much to parallelize it by, and setting my events read to 0 first. And then all this piece does is split my PyPoint list into more lists. And then I have an even number of lists that I can parallelize. So I have 100 PyPoints, and I want to spread them over 8 of my cores, right? So it would be 14 times 7 is 98. So you will have PyPoint lists of 14 points each, and then you would have one PyPoint list, which will only have 2 PyPoints. Again, you can optimize this however you want, but this, for the demonstration purposes, that's what we're going to be working with. I have now a parallel for each loop where I pass in that list of PyPoint lists, and then I go in and do the exact same thing for a bulk query. List results is equal to point list with the recorded values. I specify the time range, and then I go in and pass in that config object. As the results come back, because they're paged, I go over and map them to my concurrent dictionary. To go over the events thread, I've done the same thing I did previously, is lock that events thread variable. And as we did in the bulk query, I'm catching those exceptions in case those occur. And now we have, the same output code. All right, so let's run this. Let's make sure everything looks good. Perfect. And we're running run bulk parallel. Nothing else is going to run. Perfect. How many RPCs are going to be running now? I don't know. Let's see. 8, 9. Good. I mean, those are very reasonable numbers. Very reasonable. They're in the, between 0 and something. Yeah. All right. There we go. So you see, yeah. So you have arc bulk query running 8 times, and you have the arc bulk query chunk fetch running 7 times. Remember I said we split that list up into lists of 14 pi points? And my paging config was paged by 10 pi points. So for 7 of those times, it had to go and get more data. So that's why you see those 7 arc bulk query chunk fetch calls. Whereas the last list was only 2 pi points, and you see that it came in 1 chunk. So you didn't have to do, otherwise you would see, if you had even chunks or something, you would see 8 and 8, and that would be 16. All right. So how are you guys feeling about this now? We basically combined two methods that we went over, and in some cases you will definitely see a big performance improvement here. Some thoughts about this particular method. You can use idle cores while getting the added benefit of bulk queries, which is, again, that latency hit. You definitely should use thread-safe collections and implement the locking. There's one thing I didn't mention yet, but there is a tuning parameter in Data Archive for max concurrent bulk queries. So if I had fired off 20 bulk queries at the same time, a lot of them, Data Archive would be like, no. So don't forget about that. Data Archive is meant to be a highly available server, so you have to keep track that other users are using it too. And that's why these kind of protections are put in place for the Data Archive. So we've talked about most of these things, right? Minimize calls to the server, make calls in parallel, utilize paging, and bulk queries do minimize memory footprint by paging those results, right? So now we're going to talk about one of the newer additions to the AF SDK, which is the asynchronous pattern for retrieving data. This was added in AF SDK 2.8 onwards, and the asynchronous design pattern was implemented in .NET 4.5 onwards. So if you're familiar with that, you will enjoy this next piece of software. Let us go ahead and set that up. So this is, again, exact same thing I've been doing in the past. One caveat for asynchronous calls is they are definitely more developer intensive. You do need to keep track of a lot of things, and they require a larger development effort from the user, because you have to implement the paging now. You have to implement the chunks that you want to get back. So in this case, what I'm doing, let's go to the asynchronous query. So instead of copy and pasting code here, I am going to step through it so that it might be easier to understand here. I specify a max concurrent request count, which is 8. In this case, again, similar to the max degrees of parallelism. I have a chunk size, which is going to be how many events I'm going to chunk my queries by. I have this driver method, which is going to run an async, takes in those pi points, start time, end time, constructs a time range, and then goes in and returns using async query for data, which returns an enumerable of a list of AF values. So if you see here, that's just the same exact output code. But the fun stuff happens here. So the async query for data takes in that list of pi points, AF time range, and your concurrent request count, and also instantiates a cancellation token, because in the async pattern you need to have the cancellation tokens. And then it creates these lists to track queries in progress, creates a queue, so it can queue up these queries and then fire them off. Once, let's say one completes, then it'll put something else in there, and so on and so forth. But now you see there's this chunk query object here, which I've defined as another class, which takes in, it'll chunk the queries based on pi points, it'll return those results in that query results property, and you'll have a remaining time range to query, so it'll know when to keep querying by. The actual async call happens actually right here. Pi point recorded values async. It takes in these arguments, which is a time range. It takes in the AF boundary type. I'm saying no filter expressions. Don't include filtered values. And the max count is going to be our chunk size that we specify, the 50,000. And then also pass in that cancellation token that we've been doing. It'll make a lot more sense when I actually step through the code while it's running. So let's do that. Here, populate in progress requests and queue up all the rest. So I'm only doing 8 at a time, right? So it'll queue up all the rest of the requests. Let's go here and set up a breakpoint. And so there's 100 pi points again, right? What do you think my queue is going to look like? It's a valid answer. Valid answer. All right, let it stop at my breakpoint. Any second now. All right, there we go. While tasks in progress. Now, this queries queue has 92 queries in it. So what it did was create those queries and just queue them up. And 8 are being ready to be fired right now. And once one completes, it'll put in the next, and then the next, and so on and so forth. So you're never really waiting for things to return, and you're just processing stuff on your own when you're going over this right here. When you're iterating through the results, it's filling up results as you go. So you get the illusion of performance by never having to wait. This is really useful in client-side UI applications. You can do other things while the query completes, and the client will be like, wow, this is so fast. And that's what a lot of our clients do too.
So there's a point list recorded value async method, but not a point list recorded values async method. And I was wondering, is that kind of an intentional design choice to try to steer you towards using a enumerable of high points instead of?
Yeah, so I actually am not sure what the design choice was for that. Jason, you might.
So with the recorded, so you're saying there's a. So the question was, I'll repeat it. If I'm wrong, you tell me. You said that there is a pi point list.recorded value, but no pi point list.recorded values.
No.
Async.
There's a pi point list recorded value async.
Mm-hmm.
Oh, sorry, that's what I meant. Yeah, the async versions.
Mm-hmm.
I'm trying to trying to remember. If we look at it, do we? I think.
When I was trying to use it before, where you're trying to balance like
True.
number of calls versus overall size of whatever you're getting back.
For sure.
I don't think there was a reasoning behind why we left it out, but one of the biggest consumers right now of all our async calls is actually analysis. My guess is they didn't need it. There was not the need, and we had a certain amount of time for resources to try to get it. I don't think there's an actual reason why we couldn't do it. But if I'm remembering correctly, I think my recollection is that it was a matter of resources. So if this is something that you need,
Just curious. I mean, it's just as easy to
Yeah.
using an enumerable of high points.
sure.
For sure.
And then that made me think, oh, maybe because my instinct was to try to go use the high point list.
Sure.
No, that makes complete sense.
Yeah. So if it's something you need, please bring it up at user voice. I'm trying to remember if we have already a work item to implement this. We actually have some, I know that, but I'm not sure for your specific method what you're talking about. So I hope that answers your question.
All right. So while we were talking, you can see our queries queue. Now there's only 9 queries left in that queue. It was doing stuff in the background. Now if I continue this, so ignore the time it takes here because that time is a lot because we were talking and debugging. So, but still, I just wanted to make you all aware that we have these asynchronous patterns implemented in our code, and you can use it for a variety of applications. But remember, the number of calls we make to the data archive are still 100. Like, you're still making those same RPC calls over and over again. There is no one silver bullet that will solve all your problems when it comes to querying large values from the data archive, but you have these knobs, these things you can turn to tune that performance. And the most important thing is measure your performance. If it's too slow, how slow? Where is the bottleneck? Is it on the data archive? Is it on your client? Is it in the network? Or is it you're processing stuff slowly? Several answers to that, but as always, we're here to help. Whenever this happens, give us a call, and we'll be right on it. So now let me go back to my presentation. We covered all of this stuff: serial query, parallel query, bulk query in parallel, and asynchronous query. As I said, we provide the illusion of performance for responsive UIs. Just summarize the data retrieval part of this session. This table kind of sums most of the stuff up. There's pros and cons to everything. I've seen a lot of customers just use serial because it's easy to understand and they don't need any better performance, right? But to be very frank, use serial if you have a really good reason to use serial. Then parallel, there's pros. You utilize your client cores, but the cons are you still make the several calls to the server. If your network latency is bad, it's not going to help that much. With bulk and bulk plus parallel, you're kind of you're abstracting away the paging and that latency stuff to the AF SDK, and where AF SDK is doing that for you. So you minimize calls to the server while using that dedicated thread pool and data archive. In a lot of cases, that will give you the best performance. The one big con about bulk queries is you need to have the same request across all your pipelines. So let's say for one pipeline I want only for a day, the other pipeline I want it for 5 days, a year. That's unfortunately something you can't do with bulk queries. So then you would have to go over different options. Bulk plus parallel, the pros, get the best out of bulk queries while utilizing those client cores. But again, the same con, you need to have the same request across all pipelines. How realistic is that in certain situations? I don't know, but just to let you know, you have options. With the asynchronous, the development effort is high. I didn't go over the exact code and copy and paste everything because it was like 200 lines of code. So the development effort is definitely high, but it still can be very performant in a lot of such scenarios where the effective latency is mitigated because you're processing results as they come. However, you're still making a lot of calls to the data archive, which might impact other users' performance. Stuff to keep in mind when you're developing these applications. And with that, I think we've covered enough about data retrieval, and we'll move on to the other part of data retrieval, which is going to AF and getting stuff. So I will let Jason take over for the next part of this talk. And yeah.
Thanks, Shrey. Yeah, let's see here. Let's exit out here. I'm going to go over to my VM. So what I'm here to talk to you about is other ways that we could also improve performance of your application. So one of the things is how you search. Searching is really important, right? I mean, and even if you use PSE, our PSE, we have searching of elements and stuff like that. However, I'm not sure if all of you know, there's actually a new class that has been created. It's called the AF element search. So if you guys have applications that were using find elements, unfortunately, it's actually been obsoleted. We still use it. It's in maintenance. We will fix bugs with it, but we're not putting any new features. The AF element search is the new class, and there's a couple of reasons we do it. It gives us better flexibility on what features we could add to it, like being able to search on attribute values. We can add that without actually adding a whole bunch of overloads. So that's just some reasons why we've changed how we decided to do or implemented an SDK for searching. One other thing I wanted to bring up for performance on searching, do try to use full load. So full load is when you search for an element, it actually only brings back the header. And what's in the header is the name, GUID, very little, not very much. But if you just need it, like the name or the count of the element, no need to full load. It is extra. It does cost extra. However, if you're doing almost anything else, like trying to get data off of attributes off of it, do the full load. It'll save you in the long run. In the short run, full load will all the time you saved by not doing full load, you're going to lose easily by having to load each element one by one. Again, that's increasing the amount of RPCs to the server. Okay? And lastly, what's new with the AF element search is the allowance of paging. Okay? So again, it's the illusion, right, of having performance. But what does that matter when you're trying to look at 1,000 results of elements? No one's going to be able to scroll through that. You can do it in a background thread or whatever. Go start paging some other things. Okay? So let me give you a little quick demo on what these methods, how to use this new method, AF element search. It's not that new, but it may be new for some of you if you guys were using find elements before. So let's go to that. All right. So here's the guts of it. So I'm going to, little caveat in my demo, what I'm going to do is kind of trick and cheat a little bit with, I like to show what you could do in the past and what you can do now kind of thing. So we obviously are running this all in one application space. So I don't know if you guys know this. It's kind of a trick for us where you can create an actual different AF SDK object where all the calls are made almost separately in their own process space. You use it uses a completely different branch. Everything's not shared. The memory's not shared. Different memory space. So when we do that, I can do things here, and it's not this way. I'm not cheating. There's things in memory that's loaded so that it seems like the performance the second time is faster or whatever. Just to really show you what's going on. So the first instance, I'm going to go to my AF server. It's called JKPy AF serve. I have this new green database, and I guess I can show you that. Let's see here. So in this new green database, it's just, some of you have probably seen this. It's just a very simple database with some Houston sites. You got a few caching process, extruding process. One of our more basic ones, just for demo purposes, we have. Not a very large database, but for what we're trying to show here, it'll be sufficient. So in this search, after I set the database to new green, I make the old find elements call. Okay? So in this new find elements call, you pass it the database, you search. I'm going to say I'm going to get everything. So I put star. I pass star here. Like I said, it's not a very large database. It'll be fine. The search field I'm going to search on is name. Sort. With the result that'll come back will be sorted by their name, and the sort order will be in ascending order as opposed to descending. And we'll just limit it at about 1,000. So you notice here already, this search, these parameters here limits us to what we could add later on in the future if people wanted to add some kind of new feature on what they wanted to search on. But this is the way it was before, and I'll show you how we've changed that. So again, this goes back to that full load thing. the next line, which is the AF element.load elements. By doing this, you are still able to do full load even with the old way. And this is how you would do it. But notice here again, it's 2 separate calls, which means 2 separate RPCs again. Again, something we could improve on. Okay? I'm going to get my element list. I'm just going to, in this case, I'm just going to grab the name, just print it out to screen. Nothing big. Okay? Now I'm going to show you what the new way to do it is. And anybody who writes any application starting from now, if there's no legacy application, please use the new AF element search class. All our new development will be placed into the new class, where find elements is strictly maintenance only. So with we're going to do the same thing, set the Pi system, set the database. The element search class, what you do is you call its constructor at the very beginning. And in the constructor, you pass it the database, the name. This is just some text. It's not really important what it's used for. Don't worry about it. It's any string. And then now we support this way of what values we want to filter on. So in this case, if we want to filter on the name field of an element, this is how we do it. But we could filter on description also in this. It's all just a string. Okay? Now, the search is still not done. We just made the constructor at that point. We call the object that we've instantiated and do a find objects on it. Here, we do the full load. This is how you define that I want it to load everything, because I'm going to probably make some data calls against it and things like that. Here's the page size is the argument with which we can pass how large your pages are, which you couldn't even do on the old one. That one you just specified a max count. It's like there's no paging in there. This passes back in IEnumerable, and when you iterate through this is where it will go through and then do all your paging and everything. Now, remember the full load is, I set it to true. 1 RPC, everything's done. It's not 2. Okay? So I'm going to go ahead and just run this really quick. And all it's going to do is just pretty much just print out all the results on the screen and show you that everything does work the way it's supposed to work. Okay, we can go really quickly through this. Search has been instantiated. Results, nothing is done yet. That was pretty quick, right? I mean, it did the find objects, but it actually hasn't done anything, remember. This is an IEnumerable. Now, here is where I hit F5. Whoa, it went so fast, didn't even see it. There's actually 2 sets, one on the first one and then the second one. Okay? So just wanted to show. They bring back the same results, but the coding pattern, slightly different. Hopefully the new way will help us in maintaining it, as well as be easier for you guys too. Okay? So let's move on to my next topic I wanted to talk to you about. Let's see here. Go back. So how many of you here use event frames? I've been hearing a lot about it at the conference. Everybody's telling. Great. It sounds like a lot of you are. So I don't know how many of you use capture values. It is really, really important that you do. Performance is enhanced so much by it. What capture values does is it takes all the attribute values that are associated with whatever event frame you have, and it'll store them on the AF server. There is one limitation, which is that it can only be called on a closed event frame. So they will have to be closed first. What this does is that expensive calls, like doing summaries, maybe on like large time ranges with lots of data, all that is done now offloaded to at time of capture, and not your time of search, right? You got your users there. They don't care. They just want to look at their event frames and go, hey, I want that. Give me these event frames. I don't want to redo all this, and then it's going to go into the Pi server and then redo the calculation. That's not what you want. It's one time, stored on the AF server. It's done. This also has a really important distinction too. When we make calls to static attributes, so static attributes, their values are stored on the AF server. But PyPoint obviously are not. And it's not the AF server that makes the call. Shrey kind of alluded to this. The AF server doesn't make calls to a Pi server, not directly. what's happening is that everything, you have to remember that the data references sit on the client. They're the ones who make the calls to the server, and they have to do it. But what does that mean? The data's on the client. They have the things. So you can't do filtering, or is really slow. If you want to do server-side filtering on non-static attributes, capture values is the way to go, because all the values, again, are on the server now. We can do all the server-side filtering. Everything's quick. Everything's done right there. What comes back is a much smaller list, hopefully, because you're filtering it down, and hopefully your results will be quicker. Okay? So let me show you how simple it is to do a capture values. Products like our analysis do this. So just something to know. Let me go through a demo and show you how simple it is. So I'm going to go ahead and comment out the demo search and bring through the capture values. So I have the code down here. Very similar. I have set the Pi system. I actually have, it's a 10,000 event frame database. So all it has is just 10,000 of them, really quick, for just demo purposes. This is really similar to the AF element search class. It's called the AF event frame search. You pass it the constructor just like what we did, pass it the database. Again, the name, it's just a string. And in this case, what I'm doing is there's 10,000 event frames that start with the letters EF. Okay? So what we're going to do here, again, as I showed you previously, we do a find objects, full load. Now, I'm going to bypass all the usefulness of the enumeration for this demo, because we're trying to show you capture values. I don't really care about the paging and stuff. So we're just going to just put this into a list and go. Now that I have all the event frames in that thing, what I do is I check. Now, but I remember here, I'm going to check and make sure that this event frame hasn't been captured at one point. I only want to capture those. And I also make sure that, remember I said, you can't do it on an event frame unless it's closed. So I check that as well. Then I go ahead and do the capture values. Once I do the capture values and I do a get value call, again, where does the data go to? Does it go to the Pi server? No, right? It goes to the AF server for it now. Okay? So the tag, there's an attribute on each of the event frame that's just right now pointing to sinusoids. It's just one Pi point attribute on there. So these are this call here, this get value call, no longer goes to the source data, which is the Pi data archive. I'm going to go ahead and do a check-in. Capture values does check out stuff. So make sure you do your check-in so that everything is in. Okay? So now, after I do that, I'm just going to go ahead and demonstrate that I'm going to go ahead and get only the event frames that are greater than 20. Actually, that's very interesting. I might have to change the arrow on this one. I forgot when is sinusoid greater than 20. So it'll be interesting how many values we get back. Same thing. This time we're going to do the results. With this syntax here, we're actually getting the attribute value. Okay? But this event frame search does use the capture values when it does the value comparison. Okay? And so let's go ahead and run this. It's going to tell us how many results come back. I think I commented correctly up top. Yeah, I think I did. Let me go ahead and start it up. See what that gives us. So it's going to take a little while. But I purposely gave a kind of good number. By the way, how many people have, I just want to show of hands, how many event frames do people have? We were talking, how many people have over, I don't know, at a given time, like you guys are offloading maybe some, how many people have like over like 100,000 event frames? Not many. Have over? You? Yeah. I mean, we see a lot of customers who really use this a lot. Over the years, we've tried to improve our performance of searching on event frames and things like that, and just putting them in a fast enough rate. Hopefully, we've done a good job. If not, please come to us. It looks like it's done. Let's take a look at the results. So, great, everything. It found all 10. Essentially, remember, sinusoid is just. I'm glad it happened this way. It's above 20 at this point. So it returned all 10,000 elements. Or it should have said event frames. I'm sorry about that. That's a typo. Okay? All right, next topic I wanted to talk about.
Question.
Yes, go ahead.
So, the value, I'm not sure what was it an aggregate value over on the event frame for that sinusoid, or it was just the current value?
That in this case, it was just the current value sinusoid. But you could have made it like, remember what capture values does underneath the hood is just do a get value call. So yeah, if you had one that did configuration with like average for the time range mode, time range method, it would bring back like an aggregation or something like that.
So my question is, for the event frames that are still open, let's say we do an aggregation on that event. When I'm querying those events, is there an easy way to get the aggregate up to the current time?
Yeah, we don't.
Or do I have to do that manually?
We don't. I mean, when you do a get value call, it's gonna get you what you're saying up to that point. But you can't do capture values, right? Like I said.
To get value on the event frame attribute. That's
Correct.
aggregation.
Correct.
We'll return the aggregate up to the point.
It'll follow whatever configuration you've set. So sorry, let me repeat the question because I'm just remembering that I need to repeat it or it won't get recorded here. So the question was, if the event frame is still open, and the configuration of the PyPoint data reference is such that you have doing an average or a maximum, minimum, whatever, what could we do in that case? And so my answer was, you could do a get value call, but it's going to have to go to the Pi server, and it'll do up to whatever your configuration says. Yeah. I think I saw another hand come up, or that answered the question. Okay. Okay. So let me go ahead and continue. So the next topic I would like to talk about is AF data pipe. Okay. So first of all, how many people use AF data pipes? Anybody? Okay. Great. Are you guys using the observer pattern or the normal way? Observer pattern. All right. Cool. Glad you say that. So you may not see anything that is new, but the observer pattern is the faster way. We want everybody to use the observer pattern. It's a little bit more difficult to use. What we had a lot of customers do was Pi SDK has also a data pipe structure or object that you could use. And so it was easier for when people use the Pi SDK to migrate the code to just follow the path, whatever, changes from Pi SDK to the AF SDK. However, with the iObserver pattern, everything is faster. We would totally recommend you use this. It can support 100,000 attributes and 50,000 events per second for one data pipe. So keep that in mind. These are just rough numbers. So at the end of the day, though, this observer pattern is not anything new. It actually is, even the old way with the get update events, that is actually just a wrapper around an observer. By using the observer pattern, you have a smaller memory footprint, which then minimizes how much .NET garbage collections are going to occur. Okay? One extra thing we want to ask of you, if you do use observer pattern, make sure to use the onNext method that you call. Make it as lean as possible. That's the best way to get the best performance. Okay? And if you really need it to be fast, when you pull the observer, use async. Do it asynchronously. Okay? So let me show you a quick demo of how to do that. Let's go ahead and comment out this one. All right, and then let's go down to the code. So again, same thing, setting up. We're going back to the new green database. Okay? What I have on this database here is each of the elements has actually, not all of them, but there's quite a few that have the safety attribute. So what this is doing is, again, this is our AF search class inherited to the AF attribute search. This is specifically for attribute searching. You can search for the element name, and then I said that the attribute name, though, I want it to be safety. So bring me back all those. what I'm going to do now is I'm going to prime the pump. I'm going to set the value. I'm going to set the value to 1 for all of those safety attributes. Okay. Then I'm going to go ahead and create my data pipe. Okay. Make sure to use this in a using statement or something that disposes of it to get rid of things correctly. This method here, you call on the data pipe to add. This is where you actually pass it the list of attributes you wanted to sign up for. So we're going to go ahead and pass the list of attributes that I just got from the search above. We're going to go ahead and use the data pipe to subscribe to the observer that we created right in here. Okay, now I'm going to set the values to a different value. I'm going to set it to 2 now, just to have a different value to change it up. Since I have already signed up now, I should be able to now get all of those events. I should be able to pick it up as a change from going from 1 to 2. We should get all those results here, and I'm going to go ahead and return the amount of results. I believe there's 15 safety attributes that are going to get returned, and so we should see the update value. So I'm going to go ahead and let me put a breakpoint here so we can see this. Go ahead and start this up. All right, pretty quick. So let's take a look at the results view here. I know it's going to be a little bit small, but you can see here, hopefully you can kind of see here, it says action update. So that's what tells you what is this. This was a change from 1 to 2, okay? And the source is the name of the attribute. It's called safety, and now you see that the value is 2. So we're picking up those values that something has changed, okay? And then the results count, we'll write it to the console. 15 events were found with the observer pattern. Okay? Pretty simple. One thing I actually neglected to show you. Let me show you that. I mentioned something about the observer class. So this is the thing. You have to create this class yourself. Okay? There's an observer class that needs to be created. It needs to inherit from the iObserver interface. Okay? And then remember I mentioned these are some of the methods that you need to implement on completed on error. You don't even have to put anything. This is going to be as like lean as possible. And then you have the on next. I don't have anything. All I'm doing is taking the results this results list and populating it with the values that I get back from the observer. Okay? Just one line. Just keep this as simple as possible. It'll get you your performance that you want. Okay, so that's about it for that. So that's it for that topic. All right, final topic. I know it's getting a little long, but we'll have questions and answer session right after this. Let's see. So my last topic I want to talk to you about is AF data cache. So AF data cache is essentially making another way for us to try to minimize the amount of times that we have to go to the source data to get data. We can stick any kind of values in there, and it becomes really important for many applications. Particularly, our analysis uses it a lot. It is actually the only way the analysis can even be as performant as it is today is by using AF data cache. And there are even other reasons that it's even more important that they use it. Let's go to that. So one thing I want you to know, after you subscribe, I just want to make sure everybody is aware of this. For a while, I had a lot of customers who was confused about this. When you do an AF data cache and you subscribe and you actually put data into the AF data cache, you don't automatically are able to make calls to that attribute using the AF data object off that attribute. It doesn't just work that way. It's not like, oh, okay, well, all that data is cached. I put it into the cache. I'm just going to make some data calls. It's going to automatically do it. That's not how this thing works. You actually manage your own cache. We did this because, again, I know I use this a lot, but analysis was our biggest consumer of this. And they wanted to have full control over how the data was being put into the cache. And this was the best way for them. Okay. So again, remember, the AF data object that's on the attribute, that doesn't access the data cache that you just put data into. Okay? It's only enabled on the AF data object that's returned on the add method of the AF data cache. Okay? Again, so this makes it fewer calls to the source server. And one more big, huge thing is this. And this is what analysis uses it a lot for. Think about if your application is actually in charge of both inputs and outputs. Okay? So you do some kind of transformation or calculation or wherever, you have a value. You write that value out. Your value is the most up-to-date value. And if your application wrote it to Pi, there's no guarantee when that value is actually going to get written to the archive. The archive subsystem could be busy with something. It doesn't get there. Meaning, if I have another thread or something that tries to get data from that Pi point that you wrote the data to, that doesn't mean it's going to get the data that you just wrote, right? It could be stuck in the event queue on the Pi server. So in order for you to make sure that you're returning the most up-to-date data, in the case of where your application is in charge of both input and output, use the AF data cache as well. And you have what you call like a manual mode, and you're actually just populating that thing. And then other threads would then use the AF data cache and read that data as opposed to going to the server. Okay? So let me give a little quick demo on how this stuff works. All right, let me comment out. I'm going to forget that if I don't do it sooner than later. All right. OK, so same thing. Set the system, set the database. We'll do the new green again. We're just going to use those safety attributes again. Find objects. Everything here is pretty much the same. Now, here, same thing. Make sure to use your using statement. We need to dispose of this cache, okay, after this program is done. We don't want these hanging around, okay? Cache manager, this AF data cache, we're going to add the attribute list that we just got. So essentially in this case, all the safety attributes, okay? Now, I wanted to point to this again. Notice on this attribute from the attribute list. So these are all the safety attributes. Notice if I do the data object directly off of the attribute here, this call here actually is made to the AF server since they're static attributes, right? But we're not using the cache, okay? Even though I've already added the attribute list, this hasn't done anything. Okay, if you're using this data object off of the attribute. So what you're going to see here, and I'm going to show it to you, is that when we check, there are statistics that you can check on your AF data cache. And in this case, I'm going to check the cache hit count. It's not going to hit it. It's not going to hit your cache. What you're going to need to do is, in this add, it passes back. Notice here, here's our AF data object. It comes back in this AF keyed results. You need to use the AF data objects in this AF keyed results that gets returned by this add method. Okay? Now, if we do that one, notice that we're using here, we're using we're iterating on the data cache. We're iterating and get the attribute for that one, and then that will give me the actual AF data that's returned by the add method. This interpolated value, however, will hit the cache, and you'll see it, and it'll return back and say, hey, I hit the cache. In this case, I had 15 attributes, so 15 hits. Okay? So let me go ahead and run this, assuming my application runs correctly. Okay, let's take a look. Yep. So 0 cache hits, 15. So those are my takeaways, I would say, on these things. I hope this was informative. My name's Jason King. That's my email address if you guys want. You guys can send me some emails on what I presented. If you have any questions, you can ask them now. If you don't feel comfortable asking now, you can ask me later. That's no problem. Shrey's email is also over there. Let's see. So I guess right now I'll open it up to questions. If anybody had any, I know we were kind of answering them in between, but if anybody have any more, we have about 25 more minutes, it looks like. We were told we should have allotted for that amount of time. I don't know how many questions there are, but anybody have anything? All right, we have a early done maybe. I don't know.
Yeah. I mean, we'll be hanging around. And
yeah, we can hang around. If you don't feel you can come to us, or like I said, if you rather, you can email us. Our email address was there. I don't know what else. You have. Sorry, go ahead.
Code examples.
So I was told that code examples we won't be providing you. I'm sorry. I shouldn't say anything either. Try. You email me, we'll figure something out. How about that? Okay. I was told that we won't be putting it out on a website or anything. I thought it was like, that's the first thing I was thinking. I was like, yeah, where do I put my code? And they were like, no. So email me if you really want to see the code samples, or even ask me about something about those specific code samples. Please email me. I'm more than willing to help out. Okay.
Can I suggest a lot of what you've done in there, you'll find in the PySquare forum.
That is true. That is
100%.
very true. That is very true. So.
And the bottom, like, chunk of the for the like the AF SDK reference for, if you look at one of the namespaces or something for that, like usually they've got pretty good examples.
Yeah.
Maybe there is one thing.
But especially in the bulk
Yes.
queries area.
Oh,
Yes.
yeah.
So I think
100%.
John, you post on there quite a bit.
Oh,
So
yeah.
he's actually one of our good posters. PySquare. So for everybody who didn't hear, does everybody know about PySquare? First of all, okay, that's great. That's good. I'm glad everybody knows about it. So please go on there. There is so much. I even learned from the information on there. It is some of the information there is so well thought out, and we have developers always looking through them to make sure that we try to correct everything the best we can. We sometimes, obviously, we're human, we make mistakes, but we do the best we can to try to make sure that everything there is presented correctly. So please visit it as much as you can. Please post on there. It's a really nice environment, actually. And I even try to go on there and try to post once in a while, but sometimes our development schedule gets kind of busy. So, but yes, please post. The more, the better. Any other questions? No?
On the search and query part on the first session, you guys talk a lot more on how reduce the load on the server side. But how do we monitor it stuck on the servers, or stuck on the client side, or stuck on the cost? How do we monitor that? How do we know that it's stuck on the server or it's on latency? Because on the code it just shows how many latency, how many seconds, but it doesn't show when it's stuck. How can we monitor that?
So that is a very good question. There have been conversations around having like a load index on the data archive to figure out what the data like a number between 0 and 10 that will tell you how busy your data archive is. There are efforts into that, 100%. It would help us with balancing loads when you have collectives, right? Don't know where that is in the development cycle, but that is something definitely in the future releases of the PyServer people are thinking about. The other way of doing it would be using network managed statistics on the PyServer to see what's going on, see how many consumers are signed up, see how many producers are signed up. That's one way you can gauge an idea. But my biggest point with the queries to the data archive is, remember, you're not the only one querying the data archive. So it's just the safety mechanism built into the data archive so that we can serve as many users as possible for as many of the data requests. But yeah, that load index definitely would be useful, and people are definitely working on it.
So just to repeat the question, and if I'm wrong, tell me. You're asking about, are there any like kind of performance metrics about on the server, both, I'm assuming, on the AF server and on the data archive? Okay, so that was the question. So what Shrey said is correct. Things that I could think of, things that you could use to try to see what's going on. Don't forget to use tracing. Does everybody know what tracing is here? AF tracing? What that, for you asked the question. Tracing actually has a way where you can actually set the level at which, what messages you want to come up. But essentially, it's a log of every single call that's being made out by the client. It's every single one. Like you'll see it. Performance will suck in that mode. Don't use it while you're running your application, okay? But it's great for knowing exactly what's happening. Like some people might go, oh, like when he was counting his how many calls method. Oh wait, why is that? Then you think about it, you're like, oh, that's why. That's what you use it for. Because it is the definitive way to tell what is actually being happened. And it'll happen in real time. So what it'll do is you turn on tracing on a client machine, and any calls that are made out by that client machine, you'll see it. Boom, 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 boom. Now, it's not only just AF server. It'll make it for data archive. It'll show you everything. Okay, that's one other way I can think of. I don't know if you know this in PSE. There's actually a thing that may give you an idea better of what calls are made and what they're doing, and then what the underlying cause. So I can show you that really quick if you want to see it. What I'm talking about is the RPC counts tab, which we've had for a while. Let's see if I can show you that really quickly. Or is it on the PyServer properties one? Let's see. No, it's on the PyServer properties one. Let's do that one. Sorry. Oops, cancel. So this tab right here is what I'm talking about. Okay. Each one of these tell you what calls are being made, but these calls are, if I remember correctly, these calls are, these calls are what's happening on the server. So you can have this. I don't know if, does that help?
Because I have an AF server.
Mm-hmm.
I have a lot of users.
Yeah.
So I want to know which kind of users that using a lot of loads.
Yeah.
To my
So there's another tab too now right next to it that is new. This one is new. I don't know if it's in the SP2 or happened like the last version, but it's not that. It hasn't been that long. Oh wow, I'm killing it. Look how many connections I have. So anyway, these are all the connections. So you can see who's connecting to that AF server as well. That's a new tab. The RPC metrics has been there for a while, but the connections one is something new. So take a look at these two tabs. They give you hopefully more information. I'm just trying to help you what information that we have available. Okay. So those are two things I can think of. I can't think of anything off the top of my head else that I could, like, in terms of performance and knowing what RPCs are being made so that you can kind of troubleshoot what's going on. On the tracing, they actually do have timers in there too. They have timestamps and timers. So you can see how long each call takes as well.
I think I have put at the client side, not on the...
It's on the client side. It's on the client side. But I'm assuming you're doing metrics on what your application is doing too, right? Yeah.
I also trying to monitor others' application that accessing to my...
Yeah. I mean, you can use this connections tab to find out who's doing it, first of all, then maybe put AF tracing on that machine and see what they're doing. I don't know. So that may be one way to try to troubleshoot what's going on. Okay?
So, question.
Sure.
So using the RPC metrics tab, is that for, I saw that there was like 200 count or whatever. Is that, sure. So using the RPC metrics tab, I saw that, some of them, some of the RPCs have like 200 count or whatever. Is that since the service has been restarted, or do you know, is this for all the clients?
No, I don't think it's, if I remember correctly, I think it's when I make the connection.
Okay.
So when the application makes the connection, so it's like all zeroed out.
Okay.
But during this time, it sees all these things.
And I see that there's there's client, and then there's there's other ones that are not for the client.
Yeah, they were
So
made by
that's
somebody else. I
server-wide.
didn't do anything like to analyses or stuff like that. I'm trying to see here. Yeah.
Okay.
Yeah.
Okay. All right.
Yeah. So the microphone got passed a little late, but he was asking what's on the RPC metrics. What exactly is it showing? Like, when does it start the counters for some of these things? And the answer is I believe it's when I make the connection with this client. So the PSE has made the connection. It starts doing its counters, counting up what has gone on since then. Okay. Any other questions? Oh, here you go. Oh, one sec. Let me get the microphone so I don't have to repeat it.
I'm kind of just starting development and trying to understand, looking at PyWeb API versus the AF SDK. From a performance perspective, it looks like to me that AF SDK has a lot to offer, probably more so than PyWeb API. But I'm just wondering what kind of big things separate those two paths, whether I take one or the other.
So the Web API, it's based on AF SDK actually. I mean, it really is, but it's more catered towards the multi-user type app. Okay, so there are things that it has to do in terms of it is really careful with like security, for instance, making sure that different users don't share the data between them because they may not have access to it. Things like that. So the Web API functionality is a subset of the AF SDK, for sure. Okay, but if you're creating a multi-user application, that might be the way you would go. Okay, I'm not an expert by any means on the Web API, so I can only answer so much about it. I actually haven't coded using it, but yeah, that's what I know. Yeah, John.
Just maybe to add to that, we found with some of our clients that the Web API is a great option if you can't deploy the AF SDK to machines where the application's being run.
Good point.
They want something lightweight, and it's also it's platform independent. You can run applications on non-Windows machines and get PyData, bring PyData, and make changes that way. As Jason said, it's a subset. You don't get like-for-like functionality between SDK and Web API.
Yeah, that's actually a really good point. That people they can't install things. So in the multi-user thing, right? You just have browsers, right? There's no guarantee you can have AF SDK installed on there. It needs to make the application make calls to the Pi server, AF server, show you the data, but this SDK is not installed on that browser machine, right? It's installed on some web server out there that hosts your Web API application. Okay, does that answer your question? Yeah. Okay. Yeah, but unfortunately, it is a subset. And please tell the Web API team if you need a feature. Go to the Web API team. Go to user voice. I've said this entire conference. That's like our new way. We've gotten so many features that have come to us as developers. They say, hey, user voice, this thing is getting upvoted like crazy. We got to work on this. We can't, stop everything. Go do it. Trust us. We do listen. We are listening. User voice is actually very important to us to really feel what the heartbeat of what our customers really need. Okay.
All right.
Any other questions? Sorry, was that a hand going up? No, that wasn't. Okay. All right.
Right.
Well, we still got you 11 minutes, so we'll stick around here if you guys want to talk to us, hang out, shoot the breeze. If not, have a good rest of your conference. Sorry about how cold it is in here. I'm actually battling a cold myself, and I'm like warming up my hands here. Yeah. But anyway, it was great talking to all of you, and have a good rest of the conference.
Thanks, guys.
Okay.
Yep.
Yeah.